The PK spot is 11 meters away from the goal, making it difficult to block. However, some of the world's best goalkeepers have become very good at reading players and predicting ball trajectory. However, a curved ball that deviates from its straight line trajectory is almost impossible to save. First, let's simplify it a little. An average ball is kicked at an initial velocity of 70 miles per hour, or 31.11 meters per second. Let's say at an angle of 10.3, so the ball hits the very top of the net. We then can calculate the velocity in the horizontal and vertical directions using vectors. Now that we know the horizontal velocity, we want to find the time it takes the ball to travel 11 meters to the goal. Although this equation does work, it neglects air resistance, so really it would take longer than 0.376 seconds to reach the net, but we're just approximating anyways. Curving the ball comes into play. A spinning ball has multiple forces acting upon it as it travels through the air. With the ball spinning perpendicular to the air surrounding the one side of the ball travels faster relative to the center of the ball, since both the ball and the air are moving in the same direction. According to Bernoulli's principle, this reduces the pressure on this side of the ball. On the opposite side, where the air is moving slower relative to the center of the ball, the pressure increases. This imbalance of forces causes the ball to deviate from its path. This imbalance of forces is known as the Magnus force, named after Gustav Magnus. So now we can throw some numbers back into play. Say the ball is kicked with a spin of 8 to 10 revolutions per second, or a force of 3.5 newtons. An average soccer ball weighs 450 grams, so using Newton's second law, we can calculate the acceleration on the ball would be about 8 meters per second in the horizontal direction. Then again, using kinematics, we can determine how much the ball will travel in the horizontal direction in the 0.376 seconds it takes to reach the net. As you will see, the ball deviates 0.565 meters from the straight line path. Again, this neglects air resistance, so in fact, the ball would deviate even more from the straight line path in the time that it travels through the air.